This is a demo of FlexOS. And what I've done here, I'll just be using virtual machines instead of physical hardware. The only physical hardware I have is, if you look at the bottom of the screen here, it's a Dell R620. And then all of the virtual machines and volumes are built on 1 terabyte 7.2K drives and a RAID 5. So definitely very slow storage. As far as I/O, you may not get a great idea, but it'll at least show you the functionality of FlexOS. If we start, so let's take a look. Here's what I've done. These gray blocks here are the virtual machines that I've set up. I have CentOS 7-1, -2, and -3. And then if you look at the green volumes, these are each going to contribute a different size, just so you can kind of see the different volumes. But so we have 110 gig, 130, and 140. And so that would equate to 380, but each contributor reserves 1 gig for overhead for the FlexOS system and what it does. So if we hop over to our VMware, and I'm just using ESXi here, but what we can do, if we look at our virtual machines, you'll be able to see. So as I mentioned earlier, CentOS 7-1, and you can see the name of it here or up here, and then it's going to contribute 110 gig. CentOS 2 is going to contribute 130 gig, and then CentOS 3 will be contributing 140. So if we go over to our FlexOS system, you can see here, system overview. So what we have, it shows a physical capacity of 377 gig, which I said, 380 and then minus each node was giving a gig for overhead. But if we actually go look at our front-end storage here, you can see what's actually available is 168. So you end up with a little less than half of your total, and that gets a little better as you add nodes. But what that is it mirrors every write. So when a write comes in, it's kind of like a RAID 1, except it doesn't send it to a single disk. It takes the block and writes it in 2 different locations. So if you lose a single server, that block is still live somewhere, and I'll show you that functionality. So we'll start by just mapping a couple of volumes, and we'll also look at the difference between thick and thin provisioning. So let's go back over here, and we'll start by just mapping a volume. We'll add a volume. We'll call it thick volume. And let's make it, let's say 20 gig. Okay, and if you look here, it says it's going to round it to 24. So let's go ahead and make it 24 gig. And okay. Now, we have that 24 gig. If we go back over and look at our dashboard, you can see it's 48. So what it's done is it's showing you, again, if we look at the front end of things, 24 gig is what our client will see, but in actuality, it's taking up 48 because it's going to write that to 2 locations. So what we'll do is we're going to go ahead and map that volume over to this guy here. You click on it, you can see that's what we're about to do, and then let's go ahead and map that volume. Now if we hop over to our virtual machine, let me just move this down for now. More VMs. So this is the one I've mapped it to. And then what we'll do is we'll just go ahead and we have to format and mount that drive. So let's go to our utilities and disk. So you can see it here. It says 26. There's always a little bit of a a difference. But what we'll do here is just go ahead. We're going to click on this. Go ahead and add it. We'll format the partition. And this one was test thick, so we'll just call it that. Format. And this is just Linux asking for a password. Probably do that again. Let's try that one more time. I'm not sure what happened there, but perfect. All right, we're working, and you can see the mount position was run media, Keith, and then test thick, but it's also on my desktop here. So there's our drive, and I went ahead and had this share set up so we can test this. So again, that thing is up and mounted now. If we go back and look, we have our thick volume. If we look at our dashboard, you can see it's still 48 gig of, oh, and here is the legend of what these colors mean. So if you click on that, you can see. And so what it means is this is protected space, and this over here is spare. The system's always going to hold 10% just so you can't overload the system because it needs the ability to move blocks around. So we will go back over here and take a look at our volumes. There's our thick volume. Back-end storage, you can see what's contributing here. So this is each of our disk, 110, 30, and 140 that we're all contributing, right? Now, what we'll do is I'll show you. Let's go ahead and grab a file to put into this thing. I threw a few in my lab stuff here. All right, so you can see this CentOS 6. That's a 2 gig file. That should work for us. So we'll just go ahead and copy that onto our test volume. Okay, you can see that running. We'll take a look at what we got here and see it's that all of the disk will begin to contribute to that. And so it does a pretty good job. You can see here that each disk is contributing to this right. If we go look at our dashboard, you can take a look and see what kind of I/O workloads we have going right now. It's writes. Then again, we can go back and look at our storage, and you can see everything's contributing to that. So as this thing, we'll wait for that to finish. And since I'm going to edit this video, I will just maybe speed that up. Okay, so that's finished writing. So now that's on our volume. We'll take a look over here, and you can see as everything stops, we can go back and look at our front-end volumes there, or I'm sorry, the dashboard, and our I/O has completed. And so it's still just showing 48. That was because we provisioned this as a thick volume. Now let's do the same thing. Let's go over here to our volumes and let's add a thin volume. So from our pool, we'll go ahead and add a volume. Test thin. We'll make that one 100 gig, but thin provisioned. And okay to proceed. Now if we look at our dashboard, still see there's only 48 there. We'll go back to this thin volume and map it over to that same system. We'll look at our dashboard. You can see still 48. Now, if we go over to the virtual machine, let's we got to do the same thing to get that one. So let's go ahead and uh, mount that disk. So you can see it here. Go ahead and format and mount. Test. Uh-oh. I'm good at spelling. Yep, format it. So we got 112 Linux. Okay, test thin now is on our device. So as that mounts, what happens is Linux has to write a few things on that disk. So what we should see now is we look back at this 48.4. So that's just the the little bit of information it has to put on there to mount that volume and get it going. But now what I would like to do is you can see, so that first one we did a thick provisioning, it was 24 and showed 48. But now this one, it's gonna add whatever file we have and basically double, right? So once this IO has stopped, what I would like to show you is 48.6 is still kind of doing a little work here, but let's take a look. Really, it's just, again, this is everything has to help out for protection. And then what we'll do is let's go back and, I'm sorry, dashboard here. All right, so about 48.7 is where we are, and it looks like things are slowing up. 48.8, come on. All right, we're going to call it 48.8. So let's now take a file and copy it over to that one. And again, let's see, lab stuff. This time we'll do, see what we can find here. Yeah, here's some videos. So this one's 1.2, okay? We're going to copy that and move it over to our thin volume. So it's 1.2. Let me just make sure I'm right here. So we're showing 49. So instead of it writing 1.2, it actually writes it twice. So what you're going to see is 2.4. So we'll end up, instead of being, what is that, 49, it'd be 50, 51.5 basically is about what we're looking at. So let's go ahead and copy that and paste it in here. Okay. Now you'll start to see this I/O and workload pick up again as it writes these files over to that new volume, the thin volume. So while that's running, basically what this means is if you take a look at this, what's happening is this is showing you kind of the raw stuff, at 51.3. So now that file is, let's take a look. Yeah, it's done writing there. So now that that's complete, about 51.3. So it's exactly what I said. It writes double whatever the file size is. Now again, if you just look at the front end, it'll show you what you have provisioned. But if you look at this back-end storage, you can see the disk themselves working, and then the dashboard here, 51.8 is where we are. So basically that's how it works. And if we grabbed another file, like a 2 gig file, we're at 51.9, so let's say 52. So a 2 gig file would actually, instead of going up to 54, it'll go up to about 56. And I guess I'll just show you that too. Let's take this thing here. Lab stuff. And let's see, this one, look at this. This is 4.6. So let's do this. Let's copy it. We'll put it into our thin one. And again, that was 4.6 was the file size, right? And right now we're sitting at 52. So it's probably going to end up being around, what would that be? 4.6 is 8. That's 9.2. So you're going to end up at 61.4 roughly. Oh, okay, so let's go ahead and pop that in there. It's going to start copying. You can see it start to move, and now let's really have some fun with it by doing this. We'll show you the back end. I'm going to show you that, so everything's contributing to that that I/O. And then what I'm going to do is just go ahead and shut one of these things off. So we'll take CentOS 3 here. You can watch it copying. It's doing 17.5 megabits per or megabytes per second. I'm going to power this one off. So you'll see this is going to slow down a bit, but you're not going to lose any data. Go back over and look at our, so you can see what's happening here. Now we've started the rebuild. It's taken whatever was on this drive and finding somewhere else for it. So it's finding the blocks that do not have a mirror, and it's quickly writing a mirror for them. So that's happening in the background. As you can see here, it did drop down to about 13. So we lost a little bit of our speed, but what's important is we haven't lost any data, and it's actually still copying that thing, still copying that file over. So let's go back. You can see it's writing, it's rebuilding this thing. It's starting to throw stuff in now. Let's just go ahead. We could let that run, and basically it will just rebuild it completely. But just to make it a little hairier, why don't we go ahead and start that up again? So now it was in the middle of a rebuild. It had lost that server, and now that server is going to come back online. And we'll watch it from the back end here. And I believe this, I just decided to add this, but I believe what will happen is it'll continue to write that original mirror, and then catch up with the one that's back online. Yeah, so this bottom one is the one that I kicked offline. You can see it's still contributing nothing to I/O here, and it's contributing nothing to the rebuild. And of course that is still copying, so it's back up to about 16. But again, that one that I shut off is not contributing, and you can see it's actually, as a matter of fact, its percentage is less than the others right now because it's not helping at all. Once there's mirrored blocks in place for everything, what'll happen is it will turn around and again. So you can see it'll pick back up in just a second. And again, I'll just I can speed this up since we're just watching. So you can see this machine is fully booted back up now, and it's starting to contribute to our bandwidth and rebuild. What'll happen is eventually once these files are written and it gets the opportunity, you can see the percent of used here. What it'll do is it'll move things around so these are back to being somewhat balanced. That is a basic overview of FlexOS and how that works. So again, the dashboard you can see here, we have degraded, and that was that 23.6 gig, and that's slowly going down as it rebuilds everything. This is your basically raw, and then if you look at the front end volumes, you can see what's left here. And so you have 104 thin provision, 24 thick. And this, as it rebuilds, will slowly fade away. That 21.4 that's degraded will go away. That's finished writing now. And as you watch, you'll see this is the back-end storage is doing what it does now. It's moving things around, get it squared away, so if there's another failure, it'll be ready to pick up. Thank you.